Hello guys, once again welcome to our YouTube channel Edu Hub, and as you know, this part 3 of Phython programming beginners to experts. So without wasting time, let's get started. And as you know, this course is very important for today's world, so please don't forget to like our video and share to your friends and family members. Phython Programming Beginners to Expert Part 3.
So in this tutorial, I'll be talking about the threading module in Python. Okay, so as you might know, Python is actually a slower language compared to other languages like C and C++. So in order to make it faster, or in order to make Python faster, we have a lot of ways, and one such method is threading. So we can use threadings to actually speed up our code. So I have a program here, and it is just a small 15 line of code here. So this is actually a simple program. So I have two variables called start and finish. This actually basically calculates the start time, and this calculates the finish time. So, and at the end we actually print the difference between them. So we actually know how much time our code took to actually get completed. And we also have a function here. So it's actually a simple function. What it does is it actually says sleeping for 1 second, and then it actually sleeps for a second, and then it actually prints done sleeping. So now if I just execute this program, or if I run this program, I get okay, this function get executed. So, and it actually got finished in 1 second. And now if I just run this program twice, and if I just run the program, we actually took 2 seconds to complete, and that makes sense, right? Because this function took 1 second, and when we actually executed it twice, it actually took twice the amount of time. So I have a illustration of how this works here. It's actually a nice resource that I downloaded from the internet. So this is actually a nice illustration. So what it does is this is actually a demonstration of what we actually did. So this is the function, this is the first function. When we executed it, it actually slept for 1 second, or it actually sleeps for a second, and then the second function got executed, which also sleeps for a second, and we were done. And so that is what it actually does here. So 1 second plus 1 second, so it actually takes 2 seconds, and that is how this thing works. So what you need to understand is there are two types of tasks here. So one is CPU bound task, and other is IO bound task. So CPU bound task means it actually uses CPU, or it is actually doing some calculation in the background, not simply waiting, or it is actually using the CPU in general. So it is actually using the hardware. But IO bound task means it's actually simply waiting to get user input or some kind of response from somewhere. It is not really using CPU that much, and it's just simply waiting. So for automating, or for actually speeding up such kind of tasks, I mean for actually speeding up IO bound tasks, we can actually use threading. So so I have another graph here, or another illustration here. So this is an illustration for IO bound task. So what it actually does is it actually executes the first function, and the first function actually starts sleeping for 1 second. So while we are actually not doing anything, so now we are actually not doing anything, so we are simply sleeping. So the second function actually get executed, and meanwhile the first function completes, and together both of them get completed, and it is done here. So we get an illusion of actually speeding up code, or we actually get an illusion of running multiple tasks at the same time, while it is not actually doing it. For really actually executing multiple tasks at the same time, we have to use multiprocessing, but threading can actually speed up code in some cases, but in most cases you will have to actually use multiprocessing. We'll discuss about that later. So yeah, let's discuss about threading now. So I'll actually explain it one last time. So while we wait to actually while we actually wait to receive some inputs, or while we actually simply waiting, while we are actually doing some waiting or some sleeps, or we are doing things like that, we can actually run other code at that time, and in that way we can actually speed up the program a bit. So that is everything about uh, threading in Python. So I mean, that is a theory. Now let's just look at the practicals. So so now let's see how to actually use threads in this case. So threading is actually an inbuilt standard Python library, so we can simply import it. We can import threading, and we can actually create, or we don't actually need that anymore. So now let's just create a variable called t1, and we'll say t1 is equal to threading dot thread, and inside that we'll have to pass the function that we actually want to execute. So we'll say target function, which is do. We don't have to actually execute it, we simply need to just pass that function. And now we'll just we'll actually do two things. So we'll execute that same function twice. So we'll execute it, we'll pass the same function, target is equal to do. So now let's just see what if. Okay, so the program didn't run, or we actually didn't execute the function. To actually execute it, we have to say t1 dot start, and we have to say t2 dot start. And if we just run the program, okay, let's see what happened here. So it actually said, so let's see what has happened here. So it said sleeping for 1 second, and then actually without sleeping for this so it actually said sleeping for 1 second, and then it actually sleeps for 1 second. And while that it was actually sleeping, the program or the thread actually ran further, and it actually executed the t2 thing, or the t2 thread. And while it was I mean, while the first function, or first t1 was actually executed, it actually sleeps for a second, and at that time, at that 1 second lag, t2 got executed, and so it actually prints sleeping for 1 second the second time. And that was also over, and it actually went to here, so it actually prints finished in 0.001 second. It actually took maybe 1 or 2 seconds, but it is actually printing 0.001 second, because only after that it was done sleeping. So it may have taken 1 second, or a little bit more than a second, but it has actually printed out only 0 second here. So this shouldn't actually happen. This should only be printed after executing all these threads only. So in order to actually make sure that we complete all the threads before actually printing this thing out, we can use the join method. So I'll just have to say t1 dot join, and then t2 dot join. So yeah, now this will actually ensure that all these threads are completed before actually printing out the finish time. So now if I just rerun the program, okay, so now it actually prints sleeping for a second. So when it actually sleeps for a second, while it is actually sleeping, the t2 get executed. So the function runs again, and it actually prints sleeping for 1 second again, and then both of them actually finish this, and they print done sleeping. So earlier it actually used to take us 2 seconds to actually run this function twice, but now with threads we are actually doing it in half the amount of time. So the more tasks we have, the faster the threads are going to be, or the faster the threads are going to be. So Let's actually try to execute this using a for loop. Let's actually try to execute multiple things. Now actually let's create more threads, and we actually created 2 threads, and we actually ran it, and we actually were able to do something that usually takes 2 seconds in just 1 second. So now let's add more threads, and let's see how much speed up we can actually get. So say I want to make maybe 10 threads, so I can maybe say t1 t2 3 t3 up to t10, and that's definitely going to be fine, but that's not a good practice. So let's use for loops here. So okay, so let's remove this. We don't need any of this. Okay, we'll just copy this one. That is what we only need. Everything else is going down. So now let's create a loop. We'll say for underscore in range of 10. And if you are not sure what this underscore here is, it is just a throwaway variable. So what I mean is I just need to loop over this thing. I just need to loop. I don't need a variable here. For example, if I say I here, I need to actually use that I for something. So the variable we are going to declare here are going to be of no use. So we are not going to declare a variable here. So we say underscore, and which means it's actually a throwaway variable, or we are actually not going to use it really. So we'll say t is equal to, and we'll say we'll paste that thing threading dot thread target is equal to do, and we will actually start the thread. We cannot actually use a join method here because we need it to actually execute after completing the thread. So we cannot do this because it will be executed each time before a new thread is being executed. So we need to actually remove this from here. So what we are going to do is we are going to do something. So we'll actually declare a list here called threads and set it to an empty list, and we'll append this. So we'll just say threads, we'll say threads dot append, and we'll just append this t. We'll append this thread to that list, and so we'll append this to this, we'll append t to this list. So now after that we'll have to iterate over the list, and we have to actually, and we have to say for thread in threads thread dot join. So what we are actually doing here is, we are starting our loop, or we are actually starting our thread using one loop, and then we are actually looping over those threads again, and then applying the thread dot join method there. So we are applying the dot join method to all those threads in a separate loop. So if we just simply apply this dot join method here, it's gonna run synchronously. So it's not the way we actually want it to run. So we have to use this method here. So now if we just run this program, okay, so yeah, it printed 10 times, and it was actually finished in 1 seconds, so 1.002 seconds. So a normal thing which could have actually taken 10 seconds now has been completed in 1 second. So you should have noticed the speed difference here. So this is why we actually use threads. So, and I am reminding you guys, threads are only useful for IO bound tasks, or tasks like these when we have to wait, or wait for inputs, or we are actually doing nothing. Threads help us only doing or speeding up these type of tasks. Now let's actually take a look at on how to actually add variables, or how to actually pass arguments to a function. So for example, our do function does not take any arguments. So here we are actually specifying it to sleep for 1 second. Say for example, we need to pass here the seconds manually. So instead of this predefined 1 second, we have to manually pass in the seconds. So we'll declare a variable here called seconds, and let's add an f string here, and we'll say seconds, and we have to sleep for the specified number of seconds. So yeah, so we have only modified the program a little bit. So now we can actually decide how much seconds or how many seconds we actually want to sleep. We can actually pass an argument for that. So what we actually do is we simply say args or arguments, and inside this we have to pass the arguments inside a list. So I can maybe say 2 here or whatever I want to. Okay, so now we have actually passed the arguments. We have to pass it inside a list here. So say we have a multiple arguments, we can actually put a comma here and pass that as well. So now we just don't need to modify anything else. We can just run the program, and yep, we actually did it in 2 seconds. So we have seen this before. I just wanted to show you how to actually pass arguments, uh, how to pass arguments in this. So I think you got an idea now. So now actually we are going to take a look at real life examples, or actually a real project to do or to practice threads. So now let's actually do a project based on threads actually. So we'll see a practical hands-on application or something that we can actually do with threads. So I have some code written here. So I have a list here called image URLs. These are actually the URLs of stock photos. So these are all images from various stock websites. So if I just open this in a website or in a browser, you can see that these are all normal stock photos. So in normal cases, you can actually go to the website and maybe download image. You can just save image and just download them. So let's see how to actually do this with Python. So I have a small program here. So these are all the URLs of such stock images. So I have 5 of them. So, and I also have the start time and end time calculator that actually can calculate the time actually took. So we have discussed this before, so it's not really important. So we are actually iterating through the image URL. So we are actually accessing all the individual items inside, and then what we are actually doing is we are actually using the request library to actually get the contents of the image. We are actually downloading this using the a request library, and then we are actually giving it a name. So it actually in this case we are actually taking this as the name. So this will be the name of the image we download for each URL. This portion of the URL will be the name. So then we actually open a file, and then we actually write all the downloaded data. We actually downloaded data here using the request library, and we actually write that to a file, and then we actually finally name it. We actually add a .jpeg here at the end of the file name, so actually to make it a real JPEG image. So basically all this code is doing is actually downloading image from the internet. So, and that's all it is doing. Actually it's actually starting the start time, and it actually starting the end time. This code is not needed. So now if we just run the program, let's wait, let's see how much time this is going to take. Actually this is actually going to take a lot of time. I mean, if you actually increase this, it'll actually take a lot of time, because yeah, it actually took 17 seconds. This can also actually vary according to your internet speed. So my internet speed is not that good, so it is actually slow here. So it actually took 17 seconds. So now let's actually use threads and see how to actually speed this up. We have to modify this code a little bit. All this code will be available for you. So to actually use threads, uh, we have to actually create a function first. So we don't need this. We'll actually remove this, and we'll actually say we'll define a function here called download image, and inside the braces we'll actually specify a parameter called image URL. So we have actually changed this to a function, and that function actually accepts a parameter which is the image URL. Now what we have to do is we have to actually use the concurrent futures module. We can actually use the original threading module, but this is the better one. This is actually the better one, so I have imported it. Now what we have to actually do is we'll say with concurrent, let's just with concurrent dot futures dot thread pool executor, and we'll give it a short name. We'll call it as executor, and then we'll say executor dot map. We are actually using the map method here. You have actually heard about the map method before. I have actually discussed this. So it actually takes a function and actually a list of values, and then it can actually apply that values one by one to that function. So in this case it will actually take this function, and for this image URL it will actually apply one by one items, all the items inside this image URL. So I'll say map, and we have to actually pass in the image URLs here. Okay, we have to pass in the function first, so we'll have to say download image without the braces and comma, and we have to actually apply this list to this function. Okay, we have to apply this list to this function. So okay, so now this is actually done. So now if I just run the program, let's see the time it actually takes to download the two images. So I have actually got six URLs here, 6 image URLs. So now actually let's run this without using threads and see how much time it actually takes. And if I just hit run, let's wait for it to actually get completed. Okay, the first one was actually downloaded. It is actually going to also depend on your internet speed. Okay, so my internet speed is actually not really good, but if your internet speed is actually really fast, then this should be completed even in lesser time. Okay, if we just look at here, you can see that it actually took 57 seconds or nearly 1 minute to actually download the 6 images. Now let's run this again and see the output. Let's see if it's actually going to be slower or faster. Let's run the program. Okay, it's actually downloading. 2 images have been downloaded already. Okay, 4 completed. Just 2 more to go. Okay, it's actually completed, and it actually took 59 seconds. So it's actually literally the same. I think it was actually some mistake from my part. So yeah, this is probably my internet speed thing or anything. I'm actually getting the same output here. So you may actually get a speed up here. This is probably because of my internet speed or something. But yeah, this should actually make the program faster. So since this was actually an IO bound task, we were actually sending requests to get the data and waiting for the data to actually get downloaded. So we weren't doing anything. It was actually an IO bound task. We were just simply waiting. So in such cases, threads are actually really useful. I don't know what happened here. If you just try it yourself, you may actually get a speed up. So actually threads are used when we have an IO bound task, or when we are actually simply waiting and doing nothing CPU related, or we are actually just waiting for input or waiting to actually get a response or something. So next we'll be discussing about if it was actually some kind of CPU bound task. For example, if the program was actually doing some calculation in the background, this wouldn't actually work. We need to use concurrency to actually speed up our task. We'll see that, or we'll see how to actually do such things in the next tutorial. See you then. Okay, so we actually discussed about the threading module now. So now we have seen how to actually create threads and how to run code in parallel. And now let's discuss on, actually we discussed the manual way using the threading module, or it's actually an old method, and we have newer methods to use, and we have actually a much more easier method. This was actually just to show you how the things actually work. So now let's actually take a look at the concurrent futures module. So in actually later versions of Python, they have actually added something called a thread pool executor. So we can actually use that now. So now actually we don't need any of these. So we don't need to use threads this way anymore. We don't need this thing anymore. So we can comment this out. We don't need this. Now we also don't need this threading module. We are not going to use it. We are actually the concurrent, or the thread pool executor is actually in the concurrent module. So we have to actually import concurrent dot futures dot thread. So now we have actually imported it. Now we have to actually use this with a context manager. So first of all, we have to see what a context manager is. I'll actually explain it in so I'll explain briefly what a context manager is, and what is, or why is it actually used for. So context manager, they actually allow you to allocate and release resources. So for example, we cannot use too much resources at the same time. For example, if you are actually doing some file operations, or if you are actually working with a file or a database, you have to actually close it once you stop using it, or else it is actually going to cause problem for the system crashing, and can actually cause a lot of problems. So to actually manage these type of resources, we can use context managers. uh, so that's it, that's the basic thing. You use context managers to uh, actually manage your resources, allocate them whenever needed, and deallocate them whenever actually you stop using them. So in Python, you can actually use context manager using the with statement. So you use context manager using the with statement. Now what you have to say is, you'll say you have to say is, we'll say with concurrent dot futures dot thread pool executor. We are actually using this thing. So let's just give it a small name, because we need to use this thing. So whenever we use this, we can actually shorten it or give it a shortened name. So we'll call it executor. And okay, so now we have our executor. So now if we actually now we have some options, or we can actually use some functions or methods. So one such thing is actually the submit method. So you can actually use the submit method to execute a function actually. So for example, you want to execute this do function in threads, you can use the submit method. So we'll declare a variable for it. We'll say f1, and we'll say f1 is equal to executor dot submit, and we have to actually specify the function here. We don't have to execute it. So if you want to execute it, we'll actually specify the braces here. So we don't need to execute it, we simply need to pass it. And after that, with a comma, we actually specify the arguments inside the function. So here for seconds, we can say maybe 2. Okay, so submit method, what it does is, actually submit method, it actually schedules a function to be executed, and it actually returns a future object. So I'll explain it once again. So submit method actually returns a future object. So what a future object is, it actually encapsulates the execution of our function, and it will actually let us see if the function is running or not, or it will actually let us view the state of the function, whether it is running, whether it is done or not, and it will also allow us to grab the result of the function. So if we just grab the result, we'll actually get the return value of the function. So in this function called do, we are not actually returning anything, we are actually printing it out. But if I just remove this done sleeping, if I just change it to return, I can do that. I can say return. Now it will actually return done sleeping. It instead of printing it, it will actually return the value for. So now if we still want to actually print this done sleeping, or if we just want to print this string called done sleeping, we have to actually print the return value of that function. So to actually do that, we'll actually say print f1 dot result. So now we can actually run the program. If I run the program, so it says sleeping for 2 seconds, and it actually slept for 2 seconds, and then the program finished, and we printed the finishing time, or the time that the program took to actually finish it. So now we can actually see that we actually achieved the same thing. So if I run the program again, we can actually see that we did the same thing uh, that we used to do with our normal thread method. We had to actually write a lot of line of code, and it's actually a lot less compared to that. So it's actually quite useful. So now if we actually want to run this multiple times, we can actually run the submit method multiple times. So we'll actually say F2, and we'll just copy paste that again, and let's change the second to 1. So yeah, that's it. Now let's print f2 dot result as well, which both of them should be the same anyway. Now if we just run the program, okay, the program actually took only 1 second to complete. If it actually was doing this the normal way, it should have taken 2 seconds. So now this actually this actually completed in just half the amount of time. So that's actually great, right? We saved a lot of time. So you can actually save a lot of time when we are running multiple things, or when we are actually uh, executing something multiple times, or not just 2 times, maybe 100 times, 1000 times, or we can save a lot of time. Now let's see how to actually run this multiple times, say maybe 10 times or 20 times, or how much how much time you want to run it. So we could actually use a for loop as before. We could actually use an f1, f2, f3, f2, f10, and then actually use submit method on all of them. So but that's actually not really practical, and that's a really bad practice. So actually we can use a for loop here. uh, that is also an option. So but we are actually going to use a list comprehension techniques here. We have actually discussed about list comprehensions before. You can actually check them out if you haven't already. So let's see how to actually do this. So we don't need any of this now. Okay, so now to actually use the list comprehension method, so we can actually say we can actually declare a variable. So we can actually declare a variable here called results, or whatever you want to call it, and we'll say results is equal to, and we'll declare a list here. We'll say executor dot submit, and we'll pass in the function name, and 1 second. We have to actually sleep for 1 second each time, and we'll say for underscore, this is actually a throwaway variable. We have discussed about it before. So we'll say for underscore, or a throwaway variable in range of 10. We are actually going to execute this 10 times. So now to actually get the results of this, so we have actually created a variable called results, and now actually we are running the function for 10 times. So now we have to actually print out the result, right? So we have to get the result. So to actually get the results, we can use another module in concurrent futures module called as completed. So this will actually give us an iterator that we can actually loop over, and that will actually give us the results once they are completed. So it will actually be printed out in the order they are completed. So to actually use this, we have to, okay, so we can say for f in concurrent dot futures dot concurrent dot futures dot as completed. So inside this we'll have to pass our results variable. So I'll tell you what it actually means here now. So it actually returns as an iterator, so something that we can actually loop over or iterate over, and that is actually this object. So this will actually return something that we can actually iterate over. So we are actually iterating over that using this f variable, and now we can actually print the results using the f dot results method just like before. So now if we just run this code, okay, so this thing got kicked out, the program actually started, and it actually executed 10. So now we can actually see that it actually ran it 10 times in just 1 second. Actually earlier it actually needed 1 second to execute it once, but now we can actually execute it 10 times in just 1 second. So we get a huge speed increase there, or a huge speed advantage there. So to actually prove my point, so I actually told you that this will be printed out in the order they are completed. So the first thing that is completed will be printed out first. So to actually just prove my point, I am actually going to do something here. So we'll actually declare a list here. We'll actually say, we'll actually give the different amount of seconds to sleep for this function. So for example, this function is sleeping for 1 second. So let's try and give it different values, and let's see what happens. So for example, I have a variable, or I am actually going to declare a list called seconds, and I'll actually pass in 1 2 3 4 5. And then what we actually need to do is, so now what we are going to actually do is, we are actually going to say that for, so here actually we are going to modify this. We'll say for sec in seconds. So now we are actually iterating over the seconds. So we are actually going to sleep for a particular amount of time. Let me actually just change this in the reverse order. We need to actually in 5 4 3 2 and 1. So yeah, now now everything else will be the same. So okay, so we also have to actually change the variable name a bit, because we have already taken the variable name called seconds. So we need to actually change this to something. We'll call it seconds this way. So now, so we are actually changing the variable name a bit. We are actually, so we actually changed the variable name here from seconds to secs. So we actually changed it because we already have a variable called seconds. So that is not allowed in Python. We cannot have two variables with the same name. So now let's get back to the topic. So what we are actually doing here is we have a list here with some numbers 5 4 3 2 1s, and we are actually, instead of the seconds value, we are actually passing this value there. So first it will actually sleep for 5 seconds, then 4 seconds, then 3 seconds, then 2 seconds, then 1 second. So now let's actually add an f string here and pass in the variable called seconds, so we can see how much time it actually slept or sleep. And I think that is it. So what we are basically doing here is, we are actually passing different values for the number of seconds we actually want to sleep. So now if we just run the program, so if we just take a look at here, you can see that it started by saying sleeping for 5 seconds, 4 seconds, 3 seconds, just as in the order of this list. But then when we actually if you just take a look at here, it has actually reversed. So it says done sleeping for 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. So what happened here is we actually used the as completed method. So as it was actually completed, the 1 second one was actually completed before the 5 second one. So as it was actually completed, it immediately printed it out. So instead of waiting for the whole thing to complete, it actually printed the one that was actually completed first. So that is why we can actually use as completed method to do these things. Now let's take a look at the map method. So we can actually do a lot more with map method. Map actually runs the function with every item of a list or an iterable. So for example, I have a list called seconds here, so it has some item inside it. So if I just pass this function, so for this argument I can actually pass in this list, and it will actually apply all those values to that function. So it will actually apply all those values inside the list to that function. So we can actually use the map method to do something like this, something similar. So we can actually comment out all of this. We don't need any of these. So we can actually say that results, the same variable as before, results is equal to executor dot map, and we'll pass in the function. We'll just pass in the function called do, and then the list that it should apply. So we'll apply this seconds list here. So now we have actually done that. Now in the case of map method, it will actually return the results in the order they actually started. So earlier in the as completed method, we saw that once it was actually finished, it got printed. But for this map method, it doesn't work that way. It actually prints out in the order it actually got started. So the first one, the started one was actually 5, so it will start with 5 and then it will actually end with 1. So that's how it actually works. So now we have to actually iterate over this. So I told you that it actually returns an iterator or an iteratable. So to actually iterate over it, we can actually say for result in results, and we can actually print out the result. So now if I just run the program, you can see the program actually started the normal way. It actually slept for 5 seconds, 4 seconds, 3 seconds, and if we just come here, you can actually see that it actually works or it actually printed out in the exact order it actually got started out. So we started by sleeping for 5 seconds, and we also have stopped here by sleeping for 5 seconds, or it actually printed in the same order in which it actually got started. But if you actually look at here, you can see that the time is actually, or the time took to actually complete the script was exactly the same, or actually it is actually nearly similar. So we don't actually experience any lag or any delay when using this method. This method is actually very similar, and it actually takes the same amount of time, approximately same amount of time here. So but if we just want, the only difference is that it actually prints out in the order and it actually got started. So that is the only difference between the only difference here. Now another thing that I would like to tell you is that if an exception occurs in this thread, so for example some kind of error occurred, it will not be displayed while actually it will not be shown while actually executing them. It will only be shown while retrieving the result. So it will only be shown when we actually use this, when we actually retrieve the results here. So you can actually add some kind of error exception or try exception blocks here. So it won't actually affect the execution of our program. Only if we try to retrieve it, we'll actually get an error. So that's one thing about threads. So now another thing, in our older methods, in our normal threading method, we had to actually use the dot join method to make sure that all our threads complete, and only after that it should actually execute the final time it took. So it should actually finish all the threads. So for that we actually use the dot join method. So but here we just don't need to do that because it is automatically done. So even if we just remove this, even if we just comment this out, and if we still run the program, it is going to join this automatically. The time taken for the script to be completed is being printed here, even if we don't use the join method or anything. So that is that's actually an advantage of this newer method. So it's actually a lot less complicated than our older threading method, and you can actually use or get the same functionality. So that is all about this threading method. So now we'll actually finish this by doing a real life example of downloading images from the internet. For example, if you are a person who actually does web scraping or something, you actually probably know you have to actually wait a lot of time to get the response from the internet. So we send a request and they actually give us some kind of response, and this actually takes a long time. So in such cases we can actually use these threading modules to speed that process up. We'll be doing a little bit of downloading. We'll be doing a real life example of downloading the images from the internet. This is actually a really fun project that I just got from the internet. So let's see how to actually do it. So in this tutorial I'll be talking about multiprocessing in Python. So you may have actually heard about multiprocessing. In the last tutorial we actually talked about threading in Python, and threading may or may not work. In some cases it does work, and most cases it does not work. So let's see how to actually work with multiprocessing, because this thing is actually more efficient and this can actually work better than threading. Okay, so in multiprocessing, the tasks are actually divided into different processors, and each processor can handle different processes, and that is how actually multiprocessing works. So we'll just get more into it now. Before we actually get into multiprocessing, we have to actually discuss about something called a main function in Python. You may have actually heard about main function in C or C++, but you may not have actually heard about the main function in Python. But in Python we have something called if name is equal to main. You may have actually seen this, and so let's see what this name is equal to main function actually is. So I have created a separate file here called mylib. So I have a separate file here called mylib, and I have a mult.py function or mult.py file here as well. So let me actually declare a couple of functions here. Okay, so we'll declare some basic functions here. So I'll say def add. We'll write a function to actually add two numbers x and y, and we'll just return x plus y. And we'll actually write another function to subtract x and y, and we'll return x minus y. We can also actually simply write a basic function called hello that will simply print out hello. Okay, so we have actually written three basic functions here, and one actually basically adds two numbers, second one can actually subtract two numbers, and third one simply prints out hello world. So now we can actually use this function inside another file as long as they are in the same directory or folder. I can simply say import mult, and then if I just want to access or use a function inside this, I'll say mult dot add. I can simply add two numbers, and I can actually simply print them out by putting them inside a print statement. So if I say print, and if I just run this program, you can see that we have actually used the add function from this file. So this is actually quite normal and used in a lot of places. So how does Python actually do this? The answer is, when we actually say import mult, what it actually does, it actually comes here and it actually takes all these functions and execute them even before we reach the second line. So in the first line itself, all these actually are taken and are executed. So for example, if I simply say print, maybe print something, testing or test, and if I just simply come here and if I just run the script, you can see that this test actually got printed out. uh, Simply we just imported this, but and we didn't do anything to actually print out that thing, but it simply got printed out. So what I actually saw here is, when we just simply imported this function, this thing actually is getting printed. what we what if we actually don't want that? What if we only want this thing to be executed in this file only, or in this module only we want this thing to be executed, and when this is imported it shouldn't be executed? What will we actually do in such cases? The answer is, we actually use the if name is equal to main function. So before actually doing anything else, let's just print out name here. So it'll actually, and I just come here and if I just run the program, so if we just run this program, you can see that the answer or the name value is actually printed to be mult, which is the name of the module that we actually imported it from. So we are actually getting that value. Now if we just come to this original module and if we run this program, you can see that we are actually getting the name is equal to main. So that is what this condition is actually used for. So if we say if name is equal to main, then this program should be executed. So what we are actually basically telling here is that this program or this particular statement, I can just change this. I can say test here. So what I'm basically telling here is that only if this Python file is run directly, only if this module is run directly, should this be printed, or should this part of the code be executed, or else it shouldn't be executed. So now if I just run this program, we get test here, and if I just come here and if I execute the program, we don't get that test here. So for such situations, we actually use this name is equal to main function. Okay, so now we can actually come here and just execute all the code here. So I can actually say add, or I can actually simply say print uh, add of xy, and I can specify two numbers here. Same can be done with sub, uh, and we can also just execute the hello function, and this will only be executed if we just run this module directly. And if I just run this, all these get executed, and if I run this from here, so what programmers like to do is actually add actually everything to a main function and execute the main function here. So this will actually prevent some errors, some minor errors. So now actually, if we just change this to from main to actually, if I just change this to mult, so if I just change this to mult, this the effect will actually be the opposite. So if I just come here and if I just execute the program, we can see that everything has been executed, and if I come and run this here, nothing will be executed because we have actually set it to execute in here. So that's all about if name is equal to main function. This is actually very important before actually looking at the multiprocessing module. Now let's get right into multiprocessing. So yeah, we don't need any of this now. Just remove or comment this out. Okay, so let's get started. So we mainly have two different ways, just like we saw threads. We have a manual way, and we can actually do in a newer way or a better way using the concurrent.fuses module. But first let's take a look at the manual way using the multiprocessing module. So I'll just simply say import multiprocessing as, let's give it a short name. I'll say MP for here, and we are going to import the time module just to calculate the time that it actually takes. We can also import the math module because we are actually going to do some calculations here to actually see the time difference between the time difference that we actually take while using multiprocessing and while not using multiprocessing. So let's write a program to actually do a simple calculation, and let's see the time difference they are actually going to take. So I'm actually declaring three lists here called result A, and we'll set it to an empty list. We'll actually add values later. We'll say result B, and we'll also set it to an empty list. We'll do a result C similarly. So we are having three results here. Now we actually have to declare three functions. So I'll explain to you all this stuff after we complete this. Now let's just keep on going. So I'll define a function called make calculation. Make calculation 1, 1, and we'll take a parameter called numbers, and we'll just loop over those numbers because we are actually going to take a list of numbers. So we'll say for number in numbers, and then we'll just add these numbers. We'll just say result A dot append. We'll not simply just append those numbers, we'll do some basic calculations and we'll just add those result to this number, so to that list actually. So if I just say math dot square root, so we are actually going to calculate the square root of the cube of those numbers. Seems pretty complicated, but it's pretty simple actually. So what we are basically doing is here we are actually calculating the cube of the number first, and then we are actually squaring it, and we are actually appending it to the list for each numbers in a list of number, or for each number in a list of numbers. So we are actually going to make three similar functions so that we can actually run concurrently and check for the results. So we actually have to say we actually have to change this to 2. Everything else is the same. We have to change this to B, and finally another function, and finally we'll change this to 3, and we'll just change this to C, and that's it with our functions. We'll actually make some small modifications here. So instead of cubes, we can actually do a 4 here and 5. We're just making it to work slow. We are actually trying to slow it down with some calculations, with some numbers. So now we are actually going to use the main function. We are not using multiprocessing right now, and this is not necessary, but we are still using it. This can be used with normal programs as well. So we'll say if name is equal to main, we'll say num list. We are actually passing those numbers here. So I'll say list of range of numbers. So I'll actually do a lot of numbers. Okay, so you can reduce a 0 here. Another 0. This should be fine. Now we actually are going to calculate the start time and the end time. So we'll do that with the time module. We'll say time dot time, that will actually calculate the current time, and then we'll execute those functions. So we'll say make calculation 1, and we'll pass in the num list as the argument. We'll do the same with the other two functions. And we'll do the final one, 3 num list Yep, that's it. Now let's actually calculate the end time, and we'll actually have to calculate the difference between the start time and end time to actually uh, calculate the time the program actually took. So yeah, now I think we are pretty much done. Let's just print out the difference between the start time and the end time. Yeah, that's it. Okay, end minus start actually. Yeah, that's it. We are looking good. Let's just run this program. I'll just say run mult. Let's just wait for this program to get completed. This is actually going to take a little bit of time, and it can actually depend on your computer processor speed. I have an i7, so mine is actually pretty good. So yeah, this thing got completed in 11 seconds. Yours may take longer or shorter depending on your processor or your general system power or general computational power. So it actually took 11 seconds here to actually calculate 10, to actually do this calculation. So now let's actually use processing or multi-processing, and let's see how much speed up we can actually get. Okay, we have actually imported multi-processing. We now need to just use it. So I'll just come here. We can actually do both of them, and we'll just see the speed difference. So I'll say P1 is equal to MP dot processes, and we have to, this is actually similar to the threading module. We have to specify the target function, and target is actually make calculation 1 without executing it, and we have to pass the arguments as args, and we'll say num list. Okay, we have to actually pass in a tuple here. This is not, so we have to actually pass in a tuple here, so we'll say num list, and we have to actually specify a comma after that, because we actually have learned before. So if we need to specify a single item inside a tuple, we have to actually use a comma after that. This is a valid tuple. Now we need to just copy this now, and we can create two more processes. So we'll rename them. We'll say P2 and P3, and we'll just have to rename the functions as well. I'll say 2 without executing it, and 3 similarly. Yeah, now it's actually done. Okay, now we are actually again going to calculate the start time and end time for this one. So we actually did it while actually executing it normally, but now we actually have to execute this in processes, I mean as multi-processes. Now let's calculate the end time is equal to time dot time. Now inside this we have to actually start our processes. We actually did similarly with threads, so we'll have to say p1 dot start, p2 dot start, and p3 dot start. So we'll just say p2 dot start and p3 dot start. So now we are actually good to go. We are actually doing some calculation, uh, and then we are actually calculating it using multi-processing, and then we are actually doing it normally, and we are actually printing out the time. Okay, we haven't printed out the time, I think. So I'll say print inside an f string. We'll say multi-processing, just so that we can actually identify which one was which. So we'll say end time minus start time. So yeah, that's it. Now I think we are good to go. Let's just execute this. Let's just see how much time it actually took. Okay, so it actually completed in 1 second. You kidding me? It actually did all this calculation in just 1 second, and the other one actually took 11 seconds to complete. We can actually get more speed ups by just increasing this number a little bit. So instead of 1 million, I'm actually choosing 5 million here. So let's just rerun the program. Let's see what speed up we can actually get. I have run the program. Okay, my CPU fans are actually spinning really fast, so I'm getting a 9 second here using multiprocessing. Now with normal method, let's see how much it is going to take. Okay, it's actually taking too long. It should take maybe 15 to 20 seconds. I'm not sure. Okay, so we are actually done. So after struggling for 110 seconds, or PC managed, or my PC actually managed to do this. But with multiprocessing, we were just able to split the task into different processes, and we just completed in just less than 1/10 of the time. Here we just did it in less than 10 seconds. Here it actually took 110 seconds, and my PC actually froze for a few seconds. And so now we actually know why it is actually better to use multiprocessing than normally doing such heavy tasks. So this was actually the manual method. We can also use the concurrent.futures method to actually do this thing.